السلام عليكم ورحمة الله وبركاته، أسعد الله صباحكم. المرة الماضية بدينا نشرح حلينا سؤال على section 19.1 وبدينا نشرح theory ل 19.2. أعتقد أنهيته ووصلنا لإكزامبل but before continue وكان في عنا بونص لحد الآن ما حد سلم. وكنا حكينا بالثيوري بارت إنه it's very good to start with drawing. Okay, state 1, then the process from 1 to 2, and then state 2, and demonstrate each external moment and force, each linear and angular momentum on each scenario. And instead of drawing, we can write the equation in x-axis, y-axis, and on the z-axis. Okay, and here is the procedure: establish x, y, draw the diagrams, write or apply the equation of impulse and momentum, and try to benefit from kinematics to find out relation of omega with the velocity. So let's see this example. Here we have 30 kilogram wheel. So here we have wheel, and its mass is 30 kilogram. Has a radius of gyration about its mass center O of KO. So this is radius of gyration, 400 millimeter. If the wheel is subjected to a couple moment, 300 Newton meter, determine its angular velocity 6 seconds after it starts from rest, and consider or assume that there is no slip. Okay. So here in this problem, we have force, we have general bend motion, that means we have acceleration, and then we have time. So this is the first time this type of problem appears, so directly you must know that this type of problem is straightforward and it's easiest to solve it using chapter 19. Okay, so let's move to the solving board and try to solve this problem. First of all, let me write the given information. So we have mass of this wheel, which is 30 kilogram. Okay, and we have mass of gyration KO about point O about the centroid, which is 400 millimeter, or I can write 0.4 meter. And this wheel is subjected to couple moment, so moment of this wheel is 300 Newton meter. Determine the angular velocity 6 seconds after it starts from rest. So T initial is equal to 0 until, or I'll not name T0, I'll name it T1, state 1. T2 is 6 seconds. Okay, so we have state 1 and state 2. So V1 equal to 0, V2 is unknown. Okay, after it starts from rest, and there is no slip occurs. So here is the wheel. Okay, I'll start directly with the diagram. But it's not flying, it's rotate, rolling on the ground. This is equal to state 2. And the centroid is called okay. The radius of the wheel is 0.6. R is equal to 0.6, or do you know what? I will write it not here. I leave it for only, so I write it here. This is so, and procedures are equal to x. Okay, and we have couple moment. This is 3. Okay. Now, first thing, let us determine the xy coordinate system. So here is x, this is y, and I'll assume that this is the positive direction. Okay. Now, this is state 1. This is a process from 1 to 2. Okay, and here we have state 2. In state 1, it was at rest, no motion at all. In state 2, from 1 to 2, we have couple moment. Okay, we have its weight. Okay, we have friction force. Okay, and we have normal force. In state 2, the centroid is moving to this direction with linear momentum of mvo. Okay, and it will rotate with angular momentum of IOW. Okay, now let's go and write the equation. I think if you tried the 3 equation, you will end up with the result that this is the required equation. Try to solve it by using the other equation. So h at state 1 plus summation integration from t1 to t2. I write the general form first. Moment dt integration with respect to time equal to h2. Okay, now let's take a look. For cancelling the terms, let us see about which point is better to take the moment, angular moment and angular impulse. So is it good to take it about O, or to take it about the point in contact with the ground? I think we can name it as, for example, A. Okay, so at this point on the ground, I can call it A. Okay. Now, it's better actually to take the summation of moment about A. So here, if I write it about A, what we can benefit? Imagine that we take moment about this point. Okay, everything will cancel out, all the forces will cancel out except the moment. Okay, except the moment. Okay, so actually the problem is the friction force. So if we take it about A, then the friction force will cancel out. Okay. Now, if we are starting from rest, then this term is equal to 0 because we don't have angular velocity at state 1. Okay, so the term is equal to 0. Now we have a couple moment which is constant, then we'll take it outside the integration, so we'll end up with moment about A multiplied by delta t, and this is equal to, what do we have as an angular momentum about A? So about A, we have, this is as angular momentum, IOW. Okay, what else? We have linear momentum which is far away from point A. So if I multiplied mv multiplied by d, this is again angular momentum. Okay, so we have two sources of angular momentum. So this is equal to I O with respect to centroid omega 2 plus I will not write it in cross product, okay, because you know the direction. The radius, which is r, or the distance between point O and point A, is equal to the radius multiplied by mvo2. Okay, so I will call this equation, I will call it 1. How many unknowns we have here in this equation? What do you think? How many unknowns? Delta t given, the moment is given, I about O I can calculate it, omega 2 is needed, the radius given, mass for the wheel given, the velocity is unknown. So we have two unknowns. So we need to benefit from the kinematics. The kinematics says that V is equal to omega multiplied by R. Okay, so let me erase this and I'll not write it. 1, or do you know what? Keep it, and I will name this equation as 2. V2 omega 2. I'll name it 2. Then if I substitute omega or equation 1 in equation 2, so substitute equation 2, in equation 1, then we'll end up with moment multiplied by delta t is equal to I about omega 2 plus mass multiplied by radius omega 2, and this is multiplied by radius. So we have two radiuses. I will not write again, and I write square. So if I take omega squared as a common factor, this is I for the centroid plus mass multiplied by r squared multiplied by omega 2. And you can tell easily that this is from parallel axis theory. So omega 2 is equal to moment multiplied by delta t over IO plus mr squared. Okay, now everything is with us except the mass moment of inertia. I will calculate it later. So the moment that we have is 300 multiplied by 6 minus 0 delta time from 0 second to 6 seconds divided by, I will substitute it after I found it, plus mass, which is 30 kilogram multiplied by the radius, which is 0.6 squared. Now regarding the mass moment of inertia, how we can calculate it for the wheel? You know that in the statement of the problem, it gave us the radius of gyration. Okay, so from the radius of gyration, this is equal mass multiplied by KO squared. The mass of the wheel is 30, and the radius of gyration is 0.4 squared. Now using my calculator, this is equal to 4.8 kilogram meter squared. Okay, so here I write 4.8 using again my calculator. So this is 4.8 plus 30 multiplied by 6 squared 300 multiplied by 6 is equal to 115.38. This is omega, which is rad per second. So this is omega, angular momentum, angular velocity at state 2. Okay, as simple as it is. So let's check the answer. So here is the answer, 115.38 rad per second. Okay, let's see another example. This example. Okay, here in this example, we have gears A and B. So this is gear A and here is gear B of mass 10 kilogram and 50 kilogram respectively. Okay, so this gear has a mass of 10 and gear B, its mass is 50. Have radii of gyration about their respective mass centers. So radius of gyration about center A is equal to 80 millimeter and radius of gyration for gear B is 150 millimeter. If gear A is subjected to the couple moments, so here we have couple moments, determine the angular velocity of gear B 5 seconds after it starts from rest. So again here we have problem that it starts from rest. Let's move to the solving board and we'll start as usual with writing the given information. Let me first erase or open a new sheet. Okay, so what do we have here? We have two gears. So yeah, we have two gears, gear A and gear B. So here is gear A and it's fixed from the center. This is A. And we have gear B, which is again fixed from the center. This is gear B. Okay. Gear A, I'll start with the information regarding gear A. So the mass of gear A is equal to 10 kilogram and the radius of gear A from the figure is equal to 0.1 meter. The radius of gyration of gear A is equal to 80 millimeter, which is equal to 0.08 meter. We have a couple moment about the centroid of gear A, which is 10 Newton meter. So that's all for gear A. Now for gear B, gear B, what do we have for gear B? We have mass B, which is equal to 50 kilogram, and we have radius of gyration, or let's start with its radius first. RB is equal to 0.2 meter, and radius of gyration is equal to 150 millimeter, and this is eventually equal to 0.15 meter. Okay. Now we need to find omega, the angular velocity of gear B, omega B, V2 after 5 seconds. So this is at state 2. So state 1, T1 is equal to 0, while state 2 is equal to 5 seconds. Velocity 1 is 0 because it's mentioned that it starts from rest, and V2 is unknown. So in order to solve this problem, we need to draw each one separately. Okay, it's the common mistake with the students is they write the two gears together and start solving. Okay, so the best scenario is to take each gear alone. So here we have gear A, okay, and I'll start with state 1. So here is gear A, this is state 1, plus state 2, or the process from 1 to 2, and this is equal to state 2. But before doing that, let me go back to the slide and show you something. Okay, here we have gear A, which is rotate in this direction, and gear B will rotate in this direction as a result. Okay, here we have a mesh between them. Okay, so this mesh, this point will move in this direction. Okay, then once they have mesh between them, once there is contact between them, then we have reaction force. Okay, so we'll consider it whenever we'll start solving. Okay, we'll consider that we have reaction point between these two gears because we have mesh. Okay, so at state 1 there is nothing. Okay, there is no angular momentum, there is no linear momentum, there is nothing. In state 2 we have, let me change the color, we have couple moment. Okay, we have reaction force because the center, the centroid of this gear is fixed. So here we have AX, and here we have AY, and of course we have weight downward. Okay, and we have reaction force. So if it is rotate like this, we have reaction, and I will call the points between the two centers. So if I go up, I think I draw them. Yeah, there is contact. The point of the contact, I will name it as C. Okay, so this reaction force affecting on point C. Okay, do we have any other forces? No. So if this gear rotate clockwise, then we'll have angular momentum I A omega 2. Okay, do we have linear momentum? So this is H2. Do we have linear momentum? The answer is no, we have only rotation. Why? Because it's fixed from the center. This is rotation about the centroid. Okay, this is rotation about fixed point, and this fixed point is the centroid. Otherwise, if it is fixed about any other point except the centroid, then we'll have linear momentum. Okay, so the positive directions, I'll assume it to be like this. This is x, this is y, and I'll assume the positive rotation is clockwise. Okay, so applying the equation, which says that h about the centroid, its name is A, state 1, plus the summation or summation for the integration from T1 to T2, moment multiplied by dt, and this is equal h, of course this moment about A, and this is h A for state 2. So by default this is equal to 0 because it starts from rest. Now here we'll ask ourselves a question: which force will do moment about A? Let's go back to the previous sheet to answer this question. And let me change the color. So let's pick green. So this moment, of course, it will do moment about A. The weight and the reactions AX, AY will not do any moment because they passes through the centroid. The only force that will do the moment is the reaction force, F force at the point of contact, FC. Okay, so this is equal to 0. So here 0 plus we have moment A and it is directed clockwise, so it is positive moment about A multiplied by delta T. Now the reaction force will do counterclockwise moment. Okay, so this is minus Fc, this is force, multiplied by the perpendicular distance, which is the radius RA. Then this is what? This is moment. Now we need to multiply it by delta T. Okay, this is now angular momentum or angular impulse. Now this is equal to HA2. HA2, we have only one source, which is I with respect to centroid A multiplied by omega 2. Okay, so I will name this equation as equation 1. Let's now move to the new gear. Okay, I will leave the space here and I will write it on top of the drawing. So here we have gear B. Let me start from here. So this is gear B at state 1 plus process 1 to 2. This is gear B. This is process 1 to 2, and here we have state 2. This is gear B. Okay, so at state 1 we have nothing. State 2, what do we have? We have reactions. So this is B Y, and we have Vx. We have weight B. We don't have external or couple moment. Okay, we have the reaction force in the opposite direction of the previous one, and I will call it Fc. Same force, same magnitude. Do you have any other force? We have nothing. Okay, so only these four forces. Now in state 2 we have angular momentum. Okay, and this angular momentum will be in the opposite direction of gear A. So this is IB multiplied by omega B state 2. So this one I will name it omega A state 2. Now I need to write the equation for gear B. So let me put a line between these two equations. And let me use another color. I'll use brown. So state 1, the what do you know what I write it here? So we have HB1 plus summation integration moment of gear B dt, and this is equal HB state 2. Okay, of course this one will equal to 0 because it's mentioned start from rest. Okay, now I'll substitute here 0 plus, so I will go up, and I will keep same directions regarding the axes. Okay, so this is positive x, positive y, and this is the positive direction of rotation. So we have 0 for the first term. Regarding moment from process from state 1 to 2, so the weight will not do any moment because it's passed through the centroid as well as the reactions. The only one is FC. FC will create a moment and the counterclockwise, so its sign is negative. So this is negative. FC multiplied by RB multiplied by delta. Okay, then this is angular impulse. This is equal to IB omega B state 2, and because this is in counterclockwise, it will be again minus. So minus with minus will cancel out. So I will name this equation 2. Now let's take a look to these two equations. Moment about A given, time is given, reaction force due to contact between two gears unknown, radius and delta t given. Okay, I can calculate it because I have radius of gyration. Omega A is unknown. This is unknown. Okay. Now regarding the other equation, we have same unknown, which is FC. Okay, RB given, delta T given. IB I can find it. Omega B2 is needed from the problem. So we have two equations with three unknowns. So we need third equation. Or yeah, we have two equations, we need third equation. What do you think? From where we can bring it? Actually, before needing the third equation, I'll try to substitute one equation in the other. Okay, so I will substitute one equation in the other. Let me erase this one. First, and then we'll substitute it in the first equation. Let me erase it very well. So let me write equation 2 in terms of FC. So FC will equal to IB multiplied by omega B state 2 divided by RB delta T. And I will name this equation 2 instead of this one. Okay, now substitute 1 in 2 or 2 in 1. So substitute equation 2 and equation 1. Then what we've got? MA delta T MA delta T minus FC RA delta T. So instead of FC, I will write IB omega B2, which is needed, divided by RB delta T multiplied by RA delta T from the first equation, and this is equal to IA omega A at state 2. Now I will name this equation number 3. Now we need, in this equation, we have two unknowns, omega A and omega B. Of course, you can cancel out delta T with delta T. Okay, but we have in this equation two unknowns, omega B and omega A. But you know very well, if we have two gear in mesh, then the point of contact has the same velocity. This point, this is rotate in this direction and this in this direction, then this point will move in same direction. So VC from gear A is equal to VC, the point of contact, from gear B. Or, so using kinematics, omega A RA will equal omega B R, or instead of omega A, I will write omega A, which is equal to omega B RB divided by RA. And I will name this equation as equation 4. So now I will substitute equation 4 and equation 3. Okay, so instead of omega A, this one, I will write this equation. Okay, so yeah, let us move to a new page. Now substitute back equation 4 and equation 3. We got that MA, moment about A, multiplied by delta T minus IB omega B multiplied by RA divided by RB. This is equal IA. So instead of omega A, I will write omega B. Omega B in this scenario at state 2 multiplied by RB divided by RA. Put omega B in one side, then omega B will equal MA, moment about A, delta T, divided by, so this is IB multiplied by RA over RB plus IA multiplied by RB over R. Now everything is known except the mass moment of inertia. So mass moment of inertia, IA, is equal to mass A multiplied by Ka squared, and mass A is given to be 10, and the radius of gyration is 80 millimeter, which is 0.08 squared, then 0.08 squared multiplied by 10, this equal to 0.464 kilogram meter squared, and IB is equal to MB multiplied by KB squared, and this is equal to 50 multiplied by the acceleration, which is 150 millimeter. That means 0.15 meter squared. So 0.15 meters squared multiplied by 50. This is equal to 1.125 kilogram meter squared. Now, going back to this equation, omega b is equal to moment, which is given to be, I think, 10. Is that 10 in Newton? Yes, 10 in Newton. So this is 10 multiplied by the delta t, which is 5, minus 0, which is 5 again. IB is equal to 1.125 multiplied by RA, which is 0.1, divided by 0.2 plus IA 0.064, RB 0.2 divided by 0.1. So it's a matter of substitution only, nothing new. So using calculator, so 0.064 plus 0.1.2 multiplied by 1.25. So WB is equal to 72.4 rad per second. Okay, and this is the needed information. So this is omega b. We could find it, and if we go back to the slide, the correct answer for omega b is 62.4. Okay, so no need to find omega a, but if you want to find it, it will be 144. So that's it for section 19.2. Next lecture, inshallah, will start. Actually, we'll not start section 19.3. I will go back to section 16.8, because if you remember, I skipped that section. Okay, I will go back to it, explain it, solve problems, and then if we have time, we'll go back to this section. Okay, and this is the last two sections. And I need to remember that next week we'll have a quiz on Wednesday at 5 p.m. inshallah. Until that time, stay safe and see you soon inshallah.